Howdy. Today we'll be talking about artificial intelligence and early cancer detection. I'm Gemma Goddard.
And I'm David Tanase.
We will first be starting with motivations. So what is the need for AI in cancer detection? Cancer continues to be a significant public health issue. It is estimated that there are 19.3 million new cases of cancer and 10 million deaths each year. Treatments are often easier, safer, and work better. An example of this is that the 5-year survival rate of stage 1A lung cancer groups can exceed 90%, while patients of stage 4 lung cancer can be less than 10%.
Also, identifying subtle changes that signify the onset of a disease can present challenges for the human eye. Diseases hide well, and current methods can't always find them in time. Early cancer detection also helps healthcare systems by not needing complicated and costly procedures once the disease gets worse.
Before we dive too deep, we're going to take a minute to understand what AI actually is. AI is like a smart computer that learns to solve problems like humans. They use lots of data to learn from and to make informed decisions.
And two specific examples of AI include game trees and deep learning. And game trees work by trying to predict the next best move, and these are often used in games to explore every possible next move and choose the best one. The other form is deep learning, which tries to mimic the human brain, and this uses artificial neural networks with multiple layers to learn complex patterns in data. And this is the form of AI that's going to be mostly used in cancer detection since it learns to find patterns very well.
One branch of deep learning is convolutional neural networks. These networks break down images into tiny parts, analyze them, and then put them back together. These networks are good at spotting shapes and structures that matter in cancer diagnosis. An example of this being used is training a computer with many data sets of mammograms and the computer identifying potential cancerous lesions by detecting irregularities.
Another form of the neural network is the recurrent neural network, and this captures temporal patterns and long-range dependencies in sequential data. They can follow a patient's history and catch any changes that might indicate cancer development.
A real-life example of AI being applied in cancer detection is the Google DeepMind algorithm. In January 2020, a vast group of researchers developed an artificial intelligence system based on the Google DeepMind algorithm that is capable of outperforming human breast cancer detection.
Some of the current limitations are that high-quality data sets are very difficult to produce due to things such as patient privacy concerns and data breaches. The issue of data collection is still in controversy. Also, current models are like black boxes, and there's no simple way to understand the output. So an example is like when the model makes a decision, it's very hard to kind of decipher what factors went into that exact decision. There's also a risk that AI algorithms might perpetuate biases or inequalities in healthcare by reflecting the biases of the data they're trained on. Finally, patients are also sometimes hesitant to trust computers and results, so it might take some time for society to adjust and adapt to the new technology.
With this, let's explore what's next in the field of AI.
So one of the things that's heavily emphasized is diverse, high-quality data sets. So data is kind of like the foundation to all of these models. And without this diverse, high-quality data sets, the outputs aren't going to be as clean. So in the coming years, bias also needs to be improved. Also, in practice, available software is often impractical. As part of the research for this project, I talked to one of my friends' dad, who is a radiologist, and he mentioned that although these technologies would be useful, right now they're very specific to certain parts of the body or types of cancer. There should be in the future one software that combines all of these into one program.
Lastly, ethical agreements would need to be made in the case of misdiagnosis. So as we talked about earlier, there's no easy way to identify why a computer resulted in a problem. And so in the case that a computer misdiagnosed someone, we need to agree upon whose fault that is. Thank you for listening to our presentation and hope you enjoyed.